Okay, let's get started. We are going to write a full program right now, and it's labeled assignment number 1. It's the first task that you need to complete if you're going to try and get credit for this class. And so we're going to practically write it. I'm going to tell you what you don't need to do, and I'll tell you what you'll need to finish as well. I'm going to see how far I get through. It depends on how generous I want to be in terms of writing the code. I'm going to try and go as slow as possible. However, if you get stuck, let me know. Just raise your hand and say, hey, wait a minute, can you do that again or something? And that way we're all on the same page. We'll probably get through about half of this before we take a lunch break. And then we'll finish it up after lunch. So if you do have a problem as we get through, you're getting an error message, something is not working for you, put a little comment in your code or something, let me know what's going on there. And then when we break for lunch, I can come around to you individually and see what's on your screen and fix problems for you. So if you get lost, try to keep up, try to listen, continue, but at the same time, save up all your stuff. And then at lunchtime, I can get you working so that after lunch you can finish the project. And then we're going to work in with inheritance after that. So you want to go ahead and open up Eclipse and close all of the other projects that you might have opened, because we want to start fresh. And I'm going to refresh your memory just a few seconds here on what we're writing. So we're going to write a temperature class, which has 2 fields, a temperature value, which is going to be a floating point number, and a character, which is going to be a scale. And the character scale is going to be C or F for Celsius or Fahrenheit. And then we're going to make sure that the 2 fields are only accessible from the accessor methods outside of the class. So we'll start with this paragraph right here, and we'll start working with it. We're going to write some constructors and some methods as well. So we have Eclipse open, I hope, and then we're going to go into the File menu, select New, New, come down to, or actually just select the top one here. It says Java Project. And I'm going to call this one Task 1. You can call it Assignment 1. You can call it Fahrenheit Project. I'm going to call this Temp Project, or Temperature Project. And then use the default location, which is going to be in your workspace directory. And use everything else on the defaults and just press Finish. So now I have a little thing over here on the left-hand side. It says Temp Project with an empty source code directory. So click on the source code, SRS directory. I'm going to assume we all got this far. But do stop me if you want to take any extra time. Come back up to File, New. What we're going to do is add 2 classes to this. We're going to add a main driver program, and we're going to add a file that we're going to be using for temperature. Let's add the temperature file first. I like to put the temperature file first for some reason, but let's add them both at the same time as well. So File, New. This time we're going to come down here, and we're going to pick the word class, because we're going to add a class. So we're going to talk about interfaces in the second interactive session, in the second weekend. Package, we don't need to add a package. Packages, we're going to use the default package, actually. If we wanted to add a package, we can add packages, folders, working sets. These are other options you have, but let's just pick a class here. The wizard's going to automate our generation of this class. So the first class, and leave the source alone, is going to put it in the SRS directory. We can specify nothing, or we can specify a package. Let's just use the default, make our life simple. What we do need to do down here, though, is pick out a name for the class. We know that class is going to start with a T, if we're going to call it temperature. So type in what you want to call your class. Temperature, if I spelled it correctly. Temperature. Or I can actually make my slide, I'm going to call it TEMP maybe, because that way I don't have to worry about typing errors when I start making instances of this class. But call it anything you want, but make sure, well, you'll see what you call it. So it says modifiers. These are access modifiers. Remember those? We have public, private, protected. We have abstract, final class. We want to make sure we're doing public, because we want to make sure that this class is visible inside of main. And so we're going to make a public creation of this class. The superclass, we haven't talked about inheritance yet, but the superclass is going to come from object. Leave that one alone. We don't need to change anything with that. Now down here on the bottom it says which method stubs would you like to create? When we create the class, this is going to give us our automated template. It's going to put all that stuff in there for us. This is why people like Eclipse. So we know we're going to have some constructors. So this is not going to be main though. So we don't need to put in the public static void main. So unselect this one. But select constructors. Because let's say we want to put some constructors in. It'll just help us with the format. We don't have to select anything if we don't want to. Inherited abstract methods, we don't need that one. Don't select that one. So we're going to put constructors in here. It says, do you want to add comments? This is for Java docs. No, just not generate any comments because that's going to give us a lot of extra stuff in there that's going to confuse us right now. So on the bottom here, in terms of method stubs, which are going to be like little templates are going to be put in there for us, we're going to do the constructors from superclass. And then go ahead and click on finish. And we have this. We have the default package that was created for us automatically. And then we have temp in here. This is the temp class. And this is our constructor. Excuse me, this is our class. I don't have any constructors in here. Auto-generated constructor. Okay, we do have one temp. So in any case, this is the implementation or the start of our driver program. Of our temperature program. So let's go ahead and put in the class for our main program. So go ahead and click back on the SRS directory. It doesn't really matter where you click actually, but it's a little easier because it'll automatically generate this spot for the location. So click on SRS again, go back up to File, New. We're going to put another class in here because this project's going to have two classes. One's the temp, the other one's going to be main. So we're back to this screen again, and this is where I said if you click on SRS, it shows up here, which means it's going to put it in the same location over here that we started with already. This one here I'm going to call main. Main program, main driver. I just call it main. That sounds like a pretty good thing. It's going to be public just like before. Don't need any constructors in this class because it's going to be a driver class. But I do want to put in the public static void main, which is going to do that stuff for me automatically. And I'm going to unselect constructors because I don't really need any constructor templates. In fact, this didn't give me any constructor templates either. So, I mean, you don't have that much to pick from. So we have public static void main selected. And I gave it a class and it's public. If your screen looks like this, you're in good shape. If it does, go ahead and press finish. And it should look like this. So now I have public class main, and inside of public class main, I have static void main. And now I have this to-do, auto-generate method stub. So I try to put a message in here and says, what is this? You know, this is the auto-generated main. So now this program should actually work. So I'm going to test it out. So I'm going to right mouse click on it. It's not going to do anything for me, but I'm going to go down here and it says run as Java application. And just make sure I don't get any odd error messages or anything that comes up, and I don't. Not a bad idea to test the beginning of it. At least you know you're going to have a good starting point. So now what we can do is we can, make sure both of them are open and we're typing in the right one. We can see that this is an auto-generated constructor stub up here that came through. I like to, I'm kind of lazy actually. I like to do this. I don't like to parameter arguments and stuff. I just like to pull this stuff out. I don't know. You can take out the comments if you want to take out the comments. It doesn't really matter. So let's start with temperature first. Because temperature is really the meat of this. And main is just going to make a new instance of the temperature class for us. So click on the temperature, make sure temperature is visible. And what we're going to do here is define our data. And I got some cheat sheet notes because I don't have to keep going back and forth between the assignment description and stuff. But just to let you know, we're going to do this top part here. We're going to write a temperature class that has two fields. A temperature value, that's going to be a float, and then we're going to have a character. So our data is going to show up here. And I'm going to put the data members in first, and then I'm going to put the constructors second, and then I'm going to put the methods third. And it's kind of like the same format that the, sort of the same format the assignment description works in: data, constructors, and methods. This is just one design methodology that you can use. Okay, so we have value that we're going to hold, and then we're going to have, what else are we going to have? We're going to have character associated with it, and how ironic, I didn't actually put that on here, which is kind of weird. Okay, so let's just go this way here. So these are going to be private because we only want them accessible inside of the accessor methods. So up here I'm going to write the word private, and I'm going to use a, let's see, data type float because the assignment said use floats, and then I'm going to call this one value. And then I'm going to get this lovely little error message. Tell me I haven't used it yet. I know I haven't used it yet. So we're just going to say, oh, it's not used. Okay, good. So are we good this far? We made the public access method, private. It's not public. The access method we said is private. The data type is going to be called a float. And the name of our variable now is called value. Yes? Say that one more time. We never use protected unless we're going to inherit. You can put protected in there and it will do the same thing, but it's really unnecessary. So the question was, can you put protected here? You can. And what's confusing is you go online and you see a lot of examples that say protected this, protected that. But I say, why use protected when, are you going to inherit from this? No. When we see dinos in the next example, then we'll use protected in dino. When we start making, if you weren't here for the description, and we're going to make dinosaurs next. So, and we start with a base dinosaur, and then we're going to want to use different dinosaurs on top of it. So I guess there's some philosophies that, or some people that would just use protected on anything, because why are you going to build a class if you're not going to inherit from it? But you don't have to. So it's optional. You can put protected on there if you want. We need another piece of data, and this one's going to be a character piece of data, so we're going to go private character. And what is this going to be? Yep, and you're going to see why. You're going to see in a few minutes. We're going to write some driver, we're going to write some accessors and some modifiers first for these two pieces of data so we can use it. But all right, so we have a private character. What are we going to call this one? I'm going to call it scale. How's that? You can call your variables anything you want, really. And so now we're kind of done with this first paragraph, actually. What did we do? We rewrote a class, and we have a floating point, and we have a character for the scale, C or S, and we're going to make sure that the two fields can only be accessible. So they're accessors and modifiers. So I'm going to wait, and I'm going to write the constructors next. So if somebody creates an instance of my class in temperature, and they don't do anything, at the minimum I want to set maybe some default information. So that's what the default constructor is for, and I'm going to put some notes here and say this is the default. It's the default. In fact, here I'm going to do this actually instead, because I don't like the way the template put things together. Default. It's the default because it's not taking on any parameters. If we remember that this is empty, we can put a space in here, or we can just leave it like this. The assignment is going to say that you have to have 4 of these suckers. And each one of them, each one of the instance fields, so we have the different combinations. We have 2 variables. One of them is going to assume 0 degrees and no value is set for the Celsius if no scale is specified. And then we're going to have one with 2 parameters, one for the 2 instance variables, and then we're going to have a default setting to 0 degrees for Celsius. Okay, so we got choices. In fact, I'm going to go like this so you can sort of see both of them simultaneously. In the default, I'm going to go, I could have 2 choices. I can go this dot value. is equal to, and I have to give it, let's say, just say 0 here. Or I can simply say value. I can go this dot value is equal to 0, or I can just do this and go value is equal to 0 if I wanted to. And let's just do that because it's a little easier, a little shorter. And then I can say scale is equal to nothing. Or I could say, you know, put something in here. So this is going to make it blank, essentially, a blank character, which is a legal character, actually. But I don't even think the assignment asked me to do that. I think the assignment just said leave it. But normally you're going to see the default constructor defining both to initialize it to whatever. Just so that when you print it out to the screen, you don't get an error message, hopefully. And so we want to create 4 constructors total. So this is the first one. The second one is going to be down here. So what I need at this point is I make some space in here. In fact, I'll get rid of this bottom piece here too. So I can leave this opening, because we have an opening and closing bracket for the class temperature up here. I want to make sure I don't accidentally remove that one somehow. So I'm going to write what's called the methods that are going to be for the constructors, and I'm just going to put up the templates. So I'm going to write 4 method bodies, but I'm not going to put any code in them yet. I'm just going to define them. So I'm going to go here, public, and we can actually leave out the word public if we wanted to, and I can just go temp, but it's the same name as the class, temp. And this one here is going to take a float. I'm going to do the Taj Mahal of everything. I'm just going to do both of them together. So floats, if I can spell float correctly, F and character C. And I'm going to put in my opening and closing brackets. So that's one of another constructor. And this one here is going to be a constructor that accepts both. Accepts both. And I'll even label here constructor. Constructor that accepts both data members. But what if I want to make an instance of this class now that just takes 1? And we have 2, well, the other 2 obviously are one or the other. So I'm going to do something here. I'm going to copy and paste. So I'm going to copy this here. So I don't have to rewrite everything. And I'm going to go paste. And I'm going to take this guy out so it just takes a float. So constructor that accepts the temperature. And then I can, you know, actually I'll just do a paste again of the same one. And then this one here is going to take a character instead. So this one's got that accepts a degree. Temperature. See, that's why I don't put temperature in there. I can't spell. I'll just write temp. There we go. So we have 1, 2, 3, 4 constructors. And let me go back to my assignment. What do the constructors want me to do? So I have 4 constructors. One that takes and creates an instance, assumes 0 degrees if no value is accepted and no scale. It specifies the Celsius if no scale is specified. Okay, so out here I want to say Celsius, so I'm going to make this one turn it into a C actually then. Because I didn't read the instructions here. And instead of making it 0, I'm going to make it Celsius. Because it says here, one of the constructors is going to have an instance field, assume 0 degrees if no value is specified, and Celsius if no scale is specified. So I changed that one to a C. One with 2 parameters for the 2 instance variables, and a default one that sets the degrees, so sets 0 degrees Celsius. So here is 0 degrees Celsius is our default constructor. So down here, we're going to assume we're taking in 2 parameters. So you can possibly imagine what I'm going to write here. It's going to be something very similar to here. But I'm going to take the parameters in from the command line. So now we have F is going to be equal to, we're going to have value that's going to be equal to F. And then we're going to have scale that is going to be equal to C. You guys are with me so far? I'm trying to go slow on purpose here. Hopefully I'm not too slow for some. And then I have one here, it's just going to take f. Well, I have choices with this one. I could be smart and say, I can call this one over here, but we don't actually have to. We could do this. We could do this. But then that's going to set value to 0 and scale to C. And then we could do this and go, well, value is really equal to f. Isn't it? If I don't want to use this because I'm afraid of this, then I could go, let's say, for example, just take this piece up here and cut and paste this. So this is why we use this, so we don't have to do this. We use this so we don't have to do this. I can't paste. Oh well, let's just do this scale. So if I did this, I wrote the keyword this up here, it would take and create the value is equal to 0, scale is equal to, and then go to the next line of code and say, okay, now value is equal to f. And if I don't want to do it because I'm afraid of the keyword this, then I do it this way. Yes? Yeah, because by default we're making the scale to Celsius. It doesn't matter if you do a lower or uppercase. Nope, because we've defined scale up here, and scale is a character value. And then we took in here and we say, well, we don't have any character that's coming in up here, but we can still set the character. We can still set scale to something. And this is the name of the variable. So once we define the variable up here and give it the data type character and all the properties associated with it, we just use it. So here we can go scale, scale, scale. We don't have to say character. If we did this and said character scale, we're redefining a new one. Now we're making a new variable, and we're not using this one that's up here. If we want to, and this is why people like this, we could go this. If we do this dot scale, then we're saying, oh, it's this guy's up here. But if we're not using inheritance, we don't really have to use this either. But really this here is this dot scale. So if it helps you in the beginning, you can just use the format of putting this in here. If you're going to put it here, I'd put it everywhere else too. Yeah, if you just do this, it's assuming we're talking about this scale. It's an assumption. You want to be explicit, then you put this dot scale. Otherwise, we're talking about this scale. This scale is going to be up here. This scale up here. Say that one more time. The C is in single quotes. If I do this, I'm talking about a string. And I'm going to get a message here that says a type mismatch. It's going to say multiple markers at the same. No, it's going to say, yeah, here, down here on the bottom, it's going to say type mismatch cannot convert from string to character. So this tells me it's a string, and the single quote, the one little quote here, maybe I can zoom in here. Ah, there we go. So you got single quotes in here. That's telling me it's a character. Yeah. I'm sorry, I have to speak a little bit louder. Uh-huh. This is the C here. So, okay, so this is the little shortcut method. I could have put here user float, and then I put here user scale. And then down here, this would be user scale, and then user float. It's just the name of the variable that I'm accepting from the parameter list, and I'm taking this variable that's coming from the user, coming from the scale, that the user, so user input float, user input scale, and now the value is going to be the user input, and the scale is going to be the user input. Good question, actually, and good observation for someone who's brand new to this. It's definitely something you want to be clear about. Yes? Oh, that's what I was saying before. If I don't want to put this line of code in here, then I can just, at the top of the method, run this. Or not this, yes, this. Run this. And this is going to run, this is the word this. This will run the default constructor for me. The default, say that one more time. Correct, because the default, if you don't run another constructor, the default constructor will run. If you run one of these, the default constructor is not going to run unless you do this. Correct. Good observation. I didn't want to confuse people with this, so I just took it out. I just did scale instead. Did the long way, just to be clarification. And then the last one here, we're going to do essentially the scale is now going to be C, or scale. So scale, this is going to confuse you. Scale is going to be C, maybe not. Oops, yeah, because it's a character. So we can call this user scale, but this is the C we're talking about. Even though we're calling it, it's going to be set to C. It's kind of stupid, I guess, but. Or we could run this, actually, that would do it for us automatically. And then we're going to say value is going to be equal to 0. Technically, we don't know if this is going to be F or if this is going to be C that's coming through. So if you wanted to, I can call this a user scale. And over here we can go user scale. We good? Okay, so we have 4 constructors that we just wrote. Moving right along. Methods. So let's see what we got here. The method. Let's take one method at a time. So let's see. We're going to have write methods to return the temperature. So we're going to return temperature. One is going to return the degrees in Celsius, and the other one is going to return the degrees in Fahrenheit. And we're going to use 2 of the following formulas here to write the methods. So I'm going to do the first thing that I like to do is just write the method bodies, and then I'm going to fill it in. So I'm going to return Celsius or return Fahrenheit. But do I really want to use the word return? As I mentioned before, it's kind of a bad practice to say return. We're getting it. So we can use maybe a get Celsius or get Fahrenheit as an example, if we wanted to. Or we could name it anything we want. Let me see what I named it in here, actually. Get temperature F and get temperature C. Kind of better. So let's see. And then, so when we write the method to get temperature F and get temperature C, where did I put those on here? Here we go. We're going to return something. And the temperature is stored in a float. So the return type of the method that we're going to create is also going to be a float. And it's going to be a public method. So we're going to use the same syntax as we've been using before. So we're going to go public. Oops, if I can spell it correctly. Public. And then float is the data type of the method, which is going to be returned from the method. And public float, and we're going to say get temp C. And put some opening and closing brackets in here. And what's wrong with this? Let's take a look here. Add return type statement, yes, okay. So I'm just going to say return, for right now, just to get rid of that error message, I'm going to say return F, because F is a float. So I got rid of the error message. Well, we don't have an F in here, we have value. So I'm going to say return value. Because I don't like looking at error messages. So I have a method here that's just going to return, no conversion or anything, it's just going to return the value. So I'm going to copy this and paste it underneath. Where's my paste? Here it is. And this one's going to be the return F. So notice I used the naming convention I mentioned before, lowercase g, uppercase T, uppercase C, So I can always remember when I'm typing it. If you get into practice of actually naming stuff this way, it makes it easier. But we haven't done any conversion yet. Instead, what we've done here is we're just returning the value. Did we get this far? We now have two methods. One's called getTempC, and the other one's called getTempF. So we can now write the method bodies, and we can actually put this all on one line, or we can check. So how do we know what value we have? So I'm going to look at this as kind of my opportunity to talk about if, else, and then, which is also the other learning objective for this. If you're brand new to programming, this might be new concepts too. If you're not, then brand new, then just bear with me for a few minutes. And we have to check the scale to see what it is first. Because we're going to, and in fact, when we get done running these two methods, I'll go out into main and we'll test them out to make sure we have logical sense. So let's work with Celsius first. So we have the formula here that says degrees in Celsius and degrees in Fahrenheit. And one of them, the Celsius, is using the Fahrenheit, and the Fahrenheit is using the Celsius degree. So in here we're going to check here to see which route we're going to go. So this is the common way of checking data to see if it's this or if it's that, which is called an if-then, or we're going to actually do an if-else in this combination. So we're going to go if, and then in the if, we have opening and closing brackets that check for a condition. And the condition that we want to check for to see is scale equal to, let's just start out with C. Is scale equal to C? So we go scale equal, and we have two equals. Let me just write it first and then I'll talk about it. So this is what's called a comparison operator. We know that this isn't through osmosis because I've been using it. We know this is an assignment operator. We assign by going value equals something. This is for people who are brand new to programming. This is equals is a comparison. Whatever you put in here has to go to true or false. It's a Boolean expression. It says if true, if false. And then we have opening and closing brackets that we can put in here. So we can do this. And then at the end of the opening and closing brackets, I'll fill in the stuff in a few minutes. We can also do this. Well, if not, we can go to the end of it and say then else, if, which is just like an if, but it's an else. So if this one doesn't work, the next one's going to go. And the next one we're going to do is if scale equals f, or, yeah, there we go, f. And we're kind of assuming now that we're going to have lower and upper case. We can actually do both, check for capital C, check for lowercase c, depending upon how it was set. Or we could use a 2 upper or 2 lower or something if we wanted to. So let's see, I'm going to also put in my method, my opening and closing brackets here. Oops, not f. Scale is equal to, what's wrong with this here? I put in a double quote and a single quote mismatching, so there we go. Now I have a character. What's wrong with this? There we go. Now I have a character. And I'm going to actually move this opening bracket down here. Put it this way. There we go. So for those of you who are catching up here, this is a classic if-else statement. This is a Boolean. So if, and when I say Boolean, it means whatever you put in here has to evaluate to a true or false. You can do an assignment as well. Like, you know, if I is equal to 1, which means you're going to take I and make it equal to 1, and that assignment is going to return true or false or 0 or 1 if it's going to work or not. So if it doesn't work, it comes back error message, which is false. So, or you can put, most likely at this particular stage in development, you're going to put a comparison in here if it equals something. So this is a comparison. If I did this, I'd be assigning scale to equal to C, which I've already done in my constructors, which is going to cause a problem. So that's usually the source of confusion for some new people. I don't have to do this. I could have done an if again. The if-else is going to be part of the same structure. The if again is going to be a standalone. So let's say if scale was, and let's say for example we had larger than 10, and then down here I said and scale is larger than 20, and scale is 50 as an example, then both of them would go. If I want one or the other, I don't want both of them to trigger, I just want one or the other. Then I go else if. So this else is going to make sure that only one of these conditions is processed, not both of them. In this particular case, it's going to be a C or an F. I could have done it both ways. I could have done it with an if instead. But it's more classical, more easier to kind of understand, especially when you're working with numbers and both conditions apply. You don't want them both to fit your trigger. So this is the classic way of doing flow control with an if-else. And you can put a multiple else in here. If I had another condition, I can say, you know, else if, don't write this because this is not part of the program, but if a scale is equal to x, you know, as an example. And then I can have an opening and closing bracket as well. I can have as many as I want. There's no limitation. And at the end, let's say for example, and I'm kind of using this as a teaching example right now, so don't do this either. I could put in else without a condition, which means a dummy, you didn't have the scale set correctly or something, you know, because hey, you didn't set the scale. So this is the catch-all. This is going to happen if none of these other ones happen. Only one of these is going to happen because of the else's. If I take out the else's, it's possible that more than one of them might execute, if more than one of them are true. And they also come in sets, so we always have opening and closing brackets. You never put this inside unless you want to close it. So here's what happens, you get an error message at the end because you leave, let's say you accidentally leave this one out. And then you put, oh, okay, so put one at the end. Oh, look, it fixed the problem. But the logic's wrong. So make sure, and in fact, a lot of people will, actually that's not going to fix the problem, but it'll fix it. In some cases, it might fix it. So some people will comment out and go, check for this, check for that, check for something else. I'm really bad at comments, so I'm not putting any comments in. Actually, I tried it with the constructors. So I'm going to get rid of this one because we don't need this one, we don't need this one. What we're working with is this here. So what we really want to know is that if it's Celsius, then we're going to do something, and if it's Fahrenheit, we're going to do something. Because we're getting the temperature in Celsius, and if the temperature is already in Celsius, Celsius is pretty easy, we just return the temperature, because we're getting the temperature. We don't have to do a conversion. So we're just going to return, what are we going to return? What we called it, and I think it's what, value or something? Value. And then you see, well, we have multiple returns now. We do. In fact, we have the case in which we're going to return here. And if we return here, we're not going to go through any of the rest of the code. Another classic mistake is that a student will return. And then we'll have the rest of the function. The rest of the function, all the other assignments didn't happen. So make sure the return is the last line of code that you want to run. And then you'll be set with that. So if the scale is Celsius, return. If it's Fahrenheit, then we're going to return something else. We're going to return this formula. We're going to return, and the return we're going to do is, where's my Celsius formula? I have it written down here, actually. I have a cheat sheet of Celsius, so I don't have to actually memorize the formula here. It's going to be, what, 5 times value minus 32. So let me just copy from my notes here. So it's going to be 5 times the value minus 32 divided by 9. There we go. What's wrong? Divided by 9. Oh, I didn't put a semicolon at the end of, no, wrong formula. See, even with it written down, it's, You're right. I don't need that opening bracket there. Yeah, closing bracket. There we go. That's good, even with the formula written down already. I still have typing errors. All right, so this is the formula that's over here, actually, which is actually the same thing, but instead of using degrees and F, my formula value here is called value. So now we're returning if the scale is in Fahrenheit, we're going to return it in Celsius, and the formula for that is going to be 5 times the value minus 32 divided by 9. I'm back from, I don't know, first year chemistry or something, or I don't know what that's from. So. And we've actually completed the get temp in C function. Are we good so far with that one? If not, we'll catch up. We can leave this return here. I wonder if we take this return out and get a message here. Yeah, so remember I have a return here, then I have an else here, and I have a return here, right? This one out here shouldn't really, logically be required, but it's going to say the method must return a result of type float, because it doesn't know that you returned it in here already. So in here, I would just go return 0. And if I return 0 back, that means nothing's set, kind of thing. So here's a case in which we had to put this little extra return in the method. We put it in here only because what if this one doesn't trigger and this one doesn't trigger? Then we have to put this one in here. Yeah, it's to prevent it if this code's not reachable. We have to have a default return, which is kind of stupid, I think. But. So now I'm going to take and cut and paste the body of this message method here. Yes. Yes, we can. She's got a good suggestion, and if we were to do that, we have to declare the other variable. So I would say float temp, and then that temp would be equal to some people don't like to do it all in one shot, and then what we're going to do is return temp. Yeah, thank you for raising that question, because that's a really good question to raise.
What she's saying is keep the return
Oh.
and return the temp. And calculate the value and store it with temp.
Return temp.
In both the cases, just that.
Yeah, instead of returning 0, you mean just make a variable and make it 0 and then return the variable? Yeah, you can do that if you want to. Or you can simply, if you know it's just going to be a value, you can simply just return the value. So far, a lot of the returns you see here is like, a value. It's a data type. It's a data that we've gotten. You can actually do this if you want to. You can return -1 if you want to. Which a lot of people will do is say, hey, it's an error. When technically it is an error.
Why do we need to create a new variable? Can use
We don't. This was not necessary. This is what I thought she was asking about, actually. I thought she was asking about, because here I returned this equation. I put it all in one line instead of doing it this way.
Yeah, but I was actually saying, instead of creating a new variable,
Mm-hmm.
we can have it a variable value.
Yeah, you can return value. If it's returning value, though, you might not be returning the right thing. Because here we can return value because it's Celsius. If this fails, how do we know if it's a real value that someone put in? How do we know that that's not Celsius? So that brings up actually it's a logic scenario. You can return anything you want. If I return -1 and then out there I say float my test is equal to this temp.get temp scene, and if I return -1, function failed. And then if I return something else, show the user the temperature that was returned. It's for error checking. So a lot of functions will do this, like you create a fork a new process, fork a new thread, returns a negative number, returns something, oh, there's a problem with that. Because how do we know this is really going to work? Well, we're not really doing anything here, we're performing a calculation, but what if the value is wrong? Then there's no way of testing it if we're just going to return it. So you can put return something in here and put it make it into an error code. And then use the error code to check, well, what was it? Because in here we can actually do that as well. We can say, if there was an error in here, we tried to open up a file didn't exist. If there's an error here, return 20. Down here we'd return 10, return 5, and then use the code to determine where it's split out of all those checks, so to see what problem we might be having with that particular method. Any other questions right now? Good. So down here I believe I cut it already, but we'll see. We'll see what happens when I start pasting it in. We're going to apply the other formula and use the exact opposite reasoning here. Oops, no, I didn't cut it. Okay, so I'm going to do this instead. I'm going to cut this body here, or copy the body here and paste it in here, because I don't like typing. Now I have the same formula, but it's the wrong formula. So now I have to switch the logic. So we're accepting an F, and so if it's an F, we're going to return the value. So I'm going to pull this out here, output. And I'm just going to say return value. And then up here, I have to change the formula because the formula is going to be wrong. Paste it here. And I'm actually going to get rid of this separate line because I don't want to create a new variable. And this is the other thing too that was just kind of interesting and probably should point out. This variable temp that I created is only visible here. I can actually reuse this all over again if I want to, and it's a new temp. What happens in the method stays in the method. It's kind of like a function. What happens in the function stays in the function. So the only thing you get anything out of the function is to return something. I'll change this back to 0 too. So this is kind of the longer way of doing it, if you want. You know, if it helps with the abstraction. And so what's my formula for Fahrenheit? My formula is 9 times the value divided by 5 plus 32. So because let's see if I can type this one incorrectly. This one here is 9 times the value divided by 5 plus 32. Oops, plus 32. Oh, that one actually worked. So that one is the Celsius conversion. And now I have my Fahrenheit conversion as well. Perfect. All right. So if I go back to my cheat sheet over here, that's number 1. I created those 2 methods. And now at this point, I've done a lot of work so far. I might as well see if something's working. So I'm going to go out in main. I'm going to create some instances and see what I can run. So, and what you're going to do for this program actually is make sure that you exercise the functions that you're running. And when you run the program, it should automatically save. But I could technically at this point come up here and go File, Save if I wanted to. And make sure I save it. I'm going to switch over here. I'm pressing on my main tab here. And in my main method, which is my driver program, I'm going to make 2 instances of this object and run some instances. I'm going to forget about the command line stuff for right now. Instead, I don't have to I'm not going to ask for user input either. I'm just going to set a value and then use that value, I believe, to, let me see, I have some examples here I can possibly run. Yeah, let's just hard set the values. How's that? So I'm going to go here. I'm going to take and create 2 temperatures. So we take the name of the class that you created. Mine here is going to be temp, T-E-M-P. And I'm going to call this a, what am I going to call it? I'll just call them 1. Temp 1 is equal to new temp. And this one is using the default. This is using default constructor. Yeah, I could use that. Okay, so then I'm going to go make another one. So let's see, temp 2 is going to be equal to new temp. So what did we have? Float value and a character value. Let me see. Let's make a Fahrenheit. How's that? And then I'm going to go temp 3 is going to be equal to new temp. And what do we have? Just one that took on a value, right? And then we have a temp, oops, 4, because we have 4 constructors. And we're going to make 4 temps with these 4 constructors. It's going to be equal to a new temp. And the default is Celsius, so I'm going to make this one a Fahrenheit. I made the other one a Fahrenheit so we can convert something. So I should make this one a Celsius. So I'm going to go C in here. So just to refresh your memory on constructors, what I've done is I've exercised all 4 constructors. I've made 4 different instances of the same object. This is just a drill to show you all the different options that you can do. So do this at the top of your program because then you can exercise all 4. So this one's going to set Celsius to, it's going to set temperature to 0 and it's going to set the scale to S. So this one should be temp temp, what's it called, value. So value is actually equal to 0, and what was it, scale? It's going to be equal to a C by default. And then this one here, set value is going to be equal to 12. And I'm putting these notes in to kind of clarify for those people who are brand new to this. It's going to be F. And then this one we have a value. Maybe I'll change the value here. I'm going to make this one 15. Make it a little bit more interesting. This one here is value is going to be equal to 15. And the scale is going to be equal to, well, it's going to be equal to C. Because we didn't specify the scale. And by default, if we don't specify the scale, we're going to have it equal to C for Celsius. And while I'm doing this, you guys can finish writing your code. You don't have to put these in here if you don't want to, but the value is going to be equal to 0 because we didn't set the value. And the scale here is going to be equal to C. Did I lose anybody? So this is exercising our 4 constructors. Now let's run some methods on these. And we only have 2 methods that we wrote, actually. We have a get Celsius, and we have a get temp Celsius and get temp Fahrenheit. I'm sorry? I can go back to the temp.java file, yes. And these are the constructors that we were running. Are you getting an error message? Oh. Are we back on get temp and get temp C, get temp F? Okay. So if it's in Celsius, we're going to convert it to Fahrenheit. And if it's in Fahrenheit, we're just going to return it. This code is being recorded in a video. I'm not going to make it available to you because what's going to end up happening is people are just going to cut and paste it, turn it in. I'd rather have you, even though I'm giving you the code and we're writing it together, I'd rather have you write it together. And if you miss something, you can also, this is recorded, so you can also do it. But did you get it? Okay, perfect. All right, let's see. We're going to exercise both of the functions that we got. Now, this is kind of tedious. You don't normally would do all of this stuff, actually. But what ended up happening in the real world is you decide, well, I want to make a new instance of a temp, and what information do I have? Well, the customer entered in Celsius, but they didn't tell me what temperature. And then I'd pick and choose the constructor that I wanted to run, and then create my object that way. So this is actually giving us polymorphic behavior because we can create the object any way that we want. We have 4 different ways. You can have more than 4 constructors. You can have any number of constructors that you want, actually. Typically, you're going to have one for all the different combinations, for all of the different members that you're going to try, all the different data members that you're going to try and populate. So now I'm going to go 1 dot, and I'm using 1 because I'm taking an instance of the object. I'm going to run a method now on the object. And the object that I'm going to run is going to be it's going to be one of these 2 choices here. And these 2 choices don't take on parameters. One says get temp in Fahrenheit and get temp in Celsius. Doesn't matter which one I run. So I can go 1 dot get temp. What was the name of that method? So get temp F. That's why I wrote notes. Okay, get temp F. And then the other one could be, what did I do here? Temp, get temp. Oh, look at that. C, get temp F. It's capital F. So actually at that point, the little help actually helped me there. And I'm just going to do this one here. Just run get temp C. Well, the temp for number 1, and this is the instance of the object number 1 here, the temp is actually going to be Celsius. And we can do a couple different things with this. This is going to return a value for us. We can copy and this is the other choices you get as well. Just the same way here, I could have just returned this equation. Didn't have to write it to a variable. out here we have a lot of people that would want it to do this instead. They can go like, what are we going to return? We're going to return a float value. So we can go like, float, actually let me just write this underneath. Float my temp is going to be equal to 1 dot get temp value. And I can say, well, am I going to use my temp for something? I might use it. And then I would save this return value. See, this is going to return one time from the function. It's going to give me a value, and it's going to be the temp in Celsius, or whatever it happens to be. It will be giving Celsius. And it's going to be a float value, and I can actually save it in my temp and then use my temp all over the place. I can also do this if I wanted to. I could go system out. And for you, you're probably going to go with system out. Hello. Whoops. Let me just put some lines in. Why do I have a, what is this? Okay. System.out.print line. And I can go my temp if I wanted to. Because we saw yesterday, we can do this. And I can print it out to the screen if I wanted to. Or I can just put this in here. Hello. Actually, let's do this. Copy. Paste. And both of these work. Actually, I'm going to run the get F here. Get Fahrenheit. Because I can run one and then I can run the other. This in here, this combination here is in 2 steps, where I've cut and I've assigned it to this variable here. And then I've taken the variable and I've put it in here. And there's a breed of people that will do this, actually. And I don't recommend doing this. So look what I'm doing, but don't do what I'm doing. What do they say? Do act as I do, but don't do what I, anyway. They instead of returning this here, they would do this instead. Print out, what are you going to print out? Oh, in this case, temp, actually. So this example kind of works. Don't do. It's accomplishing the same task, but what it's doing is it's putting the system out.print line here instead of putting it out in main. What is main? It's the main driver program. It's supposed to be controlling the I/O, input-output of your program. It's supposed to be getting stuff from the user, giving stuff to the user. It's the interface. It's the public interface to the class. What you just did is put an interface inside of a class. It works just fine, but every time you run this method, it's always going to print something to the screen. What if you use this class in another driver program where you don't want it to be printed to the screen? Instead, you wanted to take this value and use it in some sort of calculation. Well, then if I do this, float my temp, get temp C, it's going to print it to the screen, whether I want to or not. And it's also going to return the value, and it's going to put the value inside of my equation here. So I can't control that behavior. So what ends up happening is what you want to do is you want to be as specific but as generic as possible. Anything that has to work with the public interface, put it in the public interface, put it in the main method. Don't do this because this here is going to make it so every time you use this method, it's going to print it to the screen. In fact, I can change it here so you can see bad idea. So when this prints out, you're going to see what happens when I run it. And I didn't run it. I ran it over here. Every time I print this out, I'm going to get bad idea printing to the screen. So at this point, we can actually run it because we have some I/O going on. And we have some variables created. So at this point, we should have a working program. So I'm going to go ahead and test it. Unless anyone has any questions before I continue forward. Okay, so I'm going to go ahead and test it here. So I'm going to go run. So I went into the project menu and I ran, see, bad idea 32, bad idea 32. How did it come up with that? Because I ran it twice. I ran this one here and then I ran it here. It was only in the, I only put it in the temp C, so I ran temp C twice. So I'm going to go over here and take away the bad idea. Actually, I just comment it out. And then now when I run it, I get the two values that I was looking for, 0.0 and 32.0. What is 32.0? And I can come up here and go, I have no idea. I guess it's, what am I printing out? The Fahrenheit of 0 is 32. So if I set the 0, I'm using 1, and 1 was created with 0 as the temperature. So now I can play around with it if I wanted to, and then say, well, which one did I set a temperature for? I set one. Actually, I set both of them on 2. Remember this one here? So I'm going to go here and change the 1 to 2. Well, actually, this isn't going to do anything. These lines of code here aren't really doing anything. It's returning it, but we're not doing anything with it. The two lines of code that are being printed out to the screen are these two with the system out next to them. And so here I can change this one to 2, and then I can change this one to 2. Now I'm going to get the second instance that I created. That method is going to, these methods are going to run on the second instance. So I should see this here. Negative 11 point something or other, and then I got 12. Well, one of them wasn't 12, so this one's actually correct. And I guess it's a negative 11 for Fahrenheit, or whatever the number. This one here was Celsius. So 12 Fahrenheit converted to Celsius is a negative something. So I guess I could change this to what, 70 degrees Fahrenheit? Let's do that, actually. If it's 70 degrees in Fahrenheit, it should give us a positive number. Let's see. It's 21 degrees in Celsius, and it's 70 degrees in Fahrenheit. And we got a question? Oh, okay, good. And we know, and going back to what I was saying about this isn't doing anything. Not printing to the screen. Not doing anything. Why are they not doing anything? We're returning something, but we're not assigning it to anything. This one takes the return value. It's the same method call. Takes the return value and assigns it to this variable here. This one is the same thing. It's just return. The return goes in here and gets printed to the screen, but it's not being stored locally. So that's one of the first things that new programmers in any language have to get familiar with is that's not doing anything. So then what ends up happening is they go back over here. Let's make it do something. Let's print it to the screen. But it's not quite the most desirable way of fixing that problem, because then you're going to have this happen every time you run the method. Yes?
I'm expecting you should use some kind of warning or error when you call a function which has a return value and you're not.
It's a legal line of code, though. It's a legal method call. Yeah, actually, look at this, for example. I'm going to make a, don't do this, but I'm going to make another method in here. And I'm going to call this one public do something. This is going to be public, let's just call it void. Do something. And this method here is going to see out to the screen. See out, let's see, system out. System.out.print line hello world. This one is also now do something. Is also, oh, I misspelled something. Here we go. Do something is inside of this. So I can go over here as an example. Just like I ran these two here that aren't doing anything, and I can go one.do something. Same as before, and it's going to print that out to the screen. So I can go over here. Hello world got printed to the screen now, which this is doing something too, but it's not printing anything to the screen. And the value is being lost, which is how when we return from functions and we don't do any error checking, then we don't have any value that's returned. So this is what we can do here. Let's say do something didn't, let me play around with do something for a second. Let's say it didn't, and it returned, actually, let's make this good. Let's check status. Check value. Check value. That's good. And then here I'm going to say, well, if value is larger than 0, okay, return 1. Or return 0. Let's return 0. else, did I just misspell return? No. Okay, else if value is smaller than 0, no, smaller than, I set to 70, right? So smaller than, larger than, or just go larger than 0. Make sure there's a value set.
Same condition.
You're right. Equals 0, how's that? If the value equals 0, what's wrong with my return statement here? Let's just see. So if it's larger than 0, then return. Return 1. How's that? And then down here, I'm going to say, I have an extra bracket in here, which is what the problem is. Return -1. What's wrong with my return? Capital? Oh, it's void. Integer. There we go. All right. So what do we got here? Extra something in here. What is this one here? This is an extra. Insert to complete the body. Okay, so we have opening and closing, opening and closing. Opening and closing, opening and closing. So this is the method opening, this is the method closing. Opening and closing, opening and closing. Why do we have this in here? Hold on one second. Oh, it's the class. It's the end of the file. This is the class closing. See, even people like me get confused occasionally. So what is that? Well, you know, if you don't know, oh, now we're going to have a problem here. What's check value? I'm sorry? Oh, you're right. I took it out. Okay, you're right. Return -1. So now I have a return of 0, a return of 1, and a return of -1. Something's going to come out of this check value. I'm going to have 3 different options that are going to come out. So out in the main, this is where this is how you do error checking, by the way. If you one way of doing error checking, you look at the return value. So I can have anything happen in here, and I'm going to return something. This could have very well just been a void function, not return something. So out in main, we don't have to do anything anymore. Instead, we're going to go here. Well, it's an integer, so integer my test is going to be equal to 1 dot, what's it called again? Check something? Check. Yeah, how come it's not coming automatically? 1 dot, there we go, check value. There we go. And then I can say if my test is equal to 0, then I'm going to do this. I'm going to go system out. And I'm going to print out value is equal to 0. And I'll test for 2 of them here. And then, you know, actually let's just do it this way. So here I have assigned a 1.check value. The return value that's going to come out of that is going to be sent to my test. And here I'm going to check my test and say, is it 0, is it 1, is it -1? But I'm only going to write one of them. I'm only writing one line code up here. And I'm going to put out here value is equal to 0. What is the value of 1? 1 is set to 0. So it actually should print. But if I change this to 2, so if I run this thing here, it's going to say value is equal to 0. If I change this instance to, the value is actually 70 in instance number 2. So if I change it out here and go 2, nothing's going to print to the screen. I'm not going to see value is equal to 0. Instead, I'm going to see the output before. So then I can test to see, oh no, the value. Then usually you're going to put here, you know, enter a value greater than 1 or something. You're going to use it for error checking to tell the user, hey, you know what, you didn't enter a value in. Because what you could do, we haven't looked at CN yet, but you could do is say, you know, hey, enter a temperature. And then You take the temperature from the user and you check this way, you could check it this way, or you can run a test on it, do a test. So let's say, for example, going back to that password example that I was running before, we have a password class object that we're going to check the password, and we have a check password. Okay, user, enter in your password. Checks in. Goes over to this function and it's going to return 0, -1, or 1, or probably just going to return 1 or 0. 1's going to be passing and 0 is going to be failure, or vice versa. And it'll go through and check and go, if this number dot length is greater than such and such, if this number contains this, if this number contains that, go all through all the checks and then finally return something. And then out in main, you're going to check the return value and say, password set successfully, thank you. Or you're going to return to the user, and the user's input's going to be, your password must be greater than 5 characters. Or your password can't be containing any special characters, or whatever happens to be the problem. So you guys can play around with that if you want, or you can add other methods to this if you want as well. Well, we're not quite done yet. We have one more thing to do. So let's take a look at this. Here we've accomplished what do we got here? Okay, so now we have to create 3 methods to set the fields. One to set the value, and one to set the scale, and one to set both together. So this is sort of like the setters, well, this is the setters and the getters. So I'll write 2 of them, you guys can write the rest of them. And so that's why I say I'm not going to write the whole thing for you, you can complete it on your own. So in the temp over here, I'm going to get rid of my check value, because that's really not part of this. And what did I do here? -1, let me just change this one to 0 again. -0 is going to give me an error. Okay, so on the bottom here, normally I would actually put the setters and the getters right after the constructor. So I'm going to do that actually. And I usually put the other methods down on the bottom. It's just a way of ordering it, but we wrote the other ones first. In fact, we already have we have a get, see, and a get. So we don't actually have to write the getters because we have the getters. So I'm going to put the setters in here. So what's the setter going to do? It's going to take a value and assign the value to the, just like the constructors. We actually wrote this code already. And we have 2 of them, and let's see if I have done anything special with them. I haven't. In fact, I don't even have them in my notes over here, so I'll just write them right now. So let's see, we'll just write a couple of them here. 3 methods here. One to set the value, one to set the scale. So let's do them both here. So we're going to have a public, because we know it's all going to start out public. And this one's going to be set, I'll just do one here, set value. And a set value is going to take on a float v. And then I'm going to have an opening and I'm going to have a closing bracket. So set value now, I didn't give a data type, so I'm going to have to call it floats. So there we go. Because it's going to return a float, and then I have to put in here, well actually it's a set, it could be void. So if you're not going to return anything, don't return anything. So in terms, you just basically, I just talked out loud and you heard my reasoning on this. I was originally going to go float on here and return float. Why should I return something? It's really void. So set is going to set something. What's it going to set? It's going to set the value equal to v. And you can go back through the constructor behavior. And this is really, the setters and the getters are used after the constructors. So the constructors only fire when the instance of the object is created. After the instance is created, we might want to set and get something. We already have the get Fahrenheit and get Celsius. So we have to write now a get, let's get the character that comes out of it. Or, so this is getting the value. So I can just do this here. Okay, I'll write all 3. So we have the second one here. This one's going to be a character C. And this one's going to set character. Set value. So this is a, what did I call that? I called it scale. Set scale. And now we're going to set the scale. Whoops, this is a capital, okay, scale. It's now going to be equal to, let's just make sure this one's different. We'll just go here, S. So now we set the scale, and then we can set them both together. So this one's going to be a combo unit. So I'll just paste this guy in here, and here's the combo. Scale, oops, character S. And then now the value is going to be equal to this one, and the scale is going to be equal to this one. There's our three methods. I wrote them all three. And we're almost done, actually. Except for we have this class thing to talk about. Class method versus instance method. Are we good? All right. So let's take I'm not going to exercise those methods out here. In fact, let me get rid of this code so it works. There we go. The rest of this stuff can stay in here. So that was part number 2. Those are those 3 methods. This is the challenge point. It's not really a challenge point. We're going to send a method. Okay, we're going to compare one temperature with another to see if, so we're going to write a compare method. And there's 2 different ways of doing this. I'm going to show you both ways. And I'm going to show you which one is probably the more preferred method, which is going to be a class method. So we can create a class or we can create an instance method to perform the same thing. The reason why the idea of a class comes up is because I'm going to compare one, they're all the same class. I'm going to compare, though, one temperature with another temperature. How do I know which one I'm going to compare to which one? And why should I make it an instance method if that's the case? Isn't it really a class functionality that's determining that? In objects that are all of the same class, if you write a class method, you can run them on all the objects of the same class, and then you can compare one class to another class. So I'm going to write them both ways so you can sort of see the difference. The comparison method will have 2 parameters. Both of the 2 parameters are objects of the temperature class. So it's going to be compare 1 with 2. Are they the same? So we're sending 2 objects of the same type to see if they're the same. The method should return, and here we go, 0, -1, and 1. I actually kind of sort of went through this already. So we kind of know we know the logic here, hopefully. So let's take a look at the method. So we're going to go back and write the method first in temperature. I'm going to stick this guy on the bottom because if I'm writing a class method, you don't have to do this. This is just my way, my design pattern. I always put the class methods on the bottom. It's easier because then you look, I'm in the habit of doing that. Other people have different styles and different approaches to this. But if I think it's going to be a class method, I'll put it on the bottom. Or if it's going to be functionality, I just add it to the bottom. But I'm not going to make the same mistake as before. I'm going to make some spaces in here so I remember I have that closing bracket. And I can just put here if I wanted to, end of class. Then I know that's what that bracket's for, because when I start writing new methods, I'm going to get confused. So I've got 2 choices here. This one here I'm going to mark for you in the code. I'm going to call this one an instance approach. Instance approach. And then we're going to make underneath it, we're going to do a class approach. And I'm going to implement this as a class approach, just so I can show you that implementation. But I want to kind of show you both so we can sort of see and compare. So the one is going to be compare 1, compare 2. Let's just write one that says compare 2. So we can make 2 methods here. And they both can exist, actually. So we always start out public, the same as before. What are we going to return? We're going to return, same thing as before, a 0, a 1, or a -1. So we're going to do what I just did before with that if-then, but actually check to see if they're equal and stuff. So public integer, and let's call this one compare me. And that sounds good to me. And what's it going to take? Well, it's actually going to take as an argument a temp. So it's going to be a temp. Actually, let's just go temp A and temp B. Temp B, here we go. And then we're going to have an opening and a closing bracket in here. And we're going to say, well, what's wrong with that? What is wrong with that? I don't put a return here. Return 0. Okay. That's what was wrong with that. Nothing was wrong with that. It's just because you didn't put, and if you don't spell it correctly either, it's going to give you a problem. All right, so there we go. This is the instance approach. If I make the class as a class, this is the same thing we've been doing before. The only thing different about this is we're taking, here, I'll just call this compare me, and then the other one I'll just call compare. And me is because it's inside of the instance. It's going to compare me to another one. And you think about the concept and you go, well, does it really need to? If I'm inside of a class and I know about me, Do I really need me information? No, I only need the other. So I can go here and say, just like here, and say temp other. I don't really need to take 2. If I'm on the class level, however, I'm going to take 2 because I'm outside of the instance environment and I'm running from a class functionality, just like math. When you ran math.square root, I'm outside. I'm going to go temp.compare2. So let's call it compare2. So now I got public, and let me just make sure I get this right. Yeah, public. If I can write the same method here, in fact here, I'm going to write the same method for you. And I'm going to show you the difference between the class and the instance here. It's going to be compare2. Compare2. And it's going to take 2 temps. It's going to take temp A, comma, temp B. And I'm going to have an opening and a closing bracket. I'm going to put in here return 0, return 0. I'm going to say, well, it looks like my other function. Except, oh, there we go. All the messages are gone away. Looks like my other function. Well, here's the key. If I put the keyword static in here, now it's not like the other functions. Now static says run this function from temp. So out here, if I were to do, there's nothing in the method bodies yet. But if I were to go here, 1.compareMe, I could send 2 in here. This is going to return something, but we're not capturing the return, but let's not worry about that right now. And what am I sending to? Well, it's expecting an argument of the temperature type. Because over here, and it's just 1, temp other. And then in here I can go, this is where the this comes into place. So this is a really, I love this exercise because it's a really good teaching aid. But so now I'm going to go 1.compare2, and I'm going to see, I'm going to generate an error message. I'm going to compare 2. What am I going to compare 1 and 2? And it should give me an error message here. It doesn't. Change access status. Oh yeah, it's going to ask me to change it, take it away. But here, this is really going to be run this way. I was kind of surprised that I did not get an error message that I was expecting with that. But this should be temperature. No, it's temp. It's called temp. This is the proper way to run this one here. So this is going to be instance compare. This is going to be class compare. From a class level, I'm putting the word temp because this is the name of my temp class. These are the same types that I'd used up here. This one's going to be compare 2. It's taking the same as before. It's taking 2 temperatures, a 1 and a 2. But it's going to do it from the outside. So inside I go A and B, A dot something, B dot something, because I'm using, we're going to write the bodies in a few minutes here and we'll see what's going on. But let's look at this one first, because then we can really see where this is actually needed, the keyword this. So we have 1 compare me to 2. So I'm going to take 1 and compare it to 2. So in the implementation of 1 compare me, I can go this. I can go here, if, what are we comparing? If the Celsiuses are equal, excuse me, if we have 2 variables to compare. We have the value and we have the scale. So I can go this dot value is equal to, what's this guy called? He's other. Other dot value. Then do something. Oops. Then go return something. Just here, return 1 or something. You can do this over here. It says means the 2, okay, 0 means the 2 temperatures are equal. So let's work at the temp first. That's the value. So if it's equal, if it equals, then it's 0. So let me put, I'll do this correctly. So it's 0. I'm sorry?
We might need to call the conversion method to compare and then compare.
Yeah, we can do that. We can compare, okay, he just brought up a good point actually. The values are interesting. They're never going to be equal unless they're both of the same type. So you can take the blind assumption and say if they're not equal, but they could be the same value, but one's in Celsius and one's in Fahrenheit. So I actually wrote some notes here, so I don't have to worry about it. So let's see. Actually, no, my notes on here didn't do it. I didn't give this to you. Instead, I'm returning this dot value and then a dot value instead. But we can write it down here. This is the tedious part of the exercise. So the logic here, let's just think it through here. The logic here is this value is equal to that. But what if we have Fahrenheit and Celsius? So we can say if Fahrenheit and Celsius, we can check for that first. If they're both, then we can go say if, let's say, for example, if scale is equal to, whoops, this is lowercase. We're going to start out with the Celsius first. Scale is equal to that, and the value of other dot scale is equal. Then we know, well, what are they then? Then inside we can go, well, if we can do this here, and this is for those people who love to write spaghetti code. And it's not really spaghetti code, this is organized. So if, for example, if they're equal, then we can say, well, if the scale then, if they're equal, then we know they're equal, we're here already. If scale, if this dot scale, we only need to check one of them at this point, is equal to Celsius, then, but we don't need to do that. What are we doing? We're just comparing. Actually, they're equal. You're right, we're equal. You're correct. I was actually going to compare them from the numbers from the value to see if 70 was equal to 32 or 11 or, whatever. So we don't need to do that anyway. I think that you guys probably get the point of what you're doing in this function. So the big main part, I'll let you write it actually. In fact, in my notes here, I did this. I just printed them out to the screen. The next one is a little easier to do actually. So if the scale is equal to the scale, then what we're looking at is other. And I remember I told you about the capital letters and stuff. I purposely made this one a capital so that you know it's an object type, so we can use the dot notation with it. So you're going to return this, else you're going to return that, else you're going to do this. Here's the three criteria that we're looking at. So we're going to check the means of the temperatures. One is higher or lower than the other one, which is, if you look at the temperatures though, what I was going to do is the hard way. If you look at it, you say, well, if you give me 70 degrees in Fahrenheit and somebody gives me 21 degrees in Celsius, they really are the same temperature. They're equals. But if I say, if this one's bigger than this one, and I'm not looking at the degrees, then I'm not going to get an accurate temperature comparison. It doesn't really matter to me, however, how you do your formula. I don't care if you're right or wrong. These are the parts that I'm looking for. So anyway, so that's how you do the instance. And the big trick here is you're just taking in one and you're using this. And this is how we know. If we did this, this would also work, but it's not as clear. Scale, what scale? We can also, when we start looking at inheritance, we can go this way. We can go this dot scale. Don't write this down because this is wrong. Super dot scale. Well, super doesn't exist because we don't have anything in the inheritance, which is why we're going to get an error message here. But super would tell us the object we inherited from also had a scale in there, and we can compare both of those two, which is still inside of this. But in this case, let's talk about that after lunch. We'll talk about super after lunch. But there's another comparison. You can go this to super. Okay, are we good so far? Let's take a look at the compare to. This is the class method implementation. I'm going to write one of them because I have my cheat sheet, and I'm not going to write the whole thing. Because then you have to go through and you have to compare the Celsius, and it's all tedious. One of them is going to do the trick for us. And then you guys can write the rest of them. It gives you something to do at least. This is the only part left in terms of the mystery. Okay, so we're going to do another if, and we're going to take A and B together and see. And I'm going to look at the Celsius right now. And this is not the complete code. It's just what I'm able to essentially write and type in front of you here. So if, what are we going to do here? A, well, I made a mistake here. I'm going to make this capital A and capital B, which is what I should have done. If capital A dot get scales, scale, did we write a get scale? Yeah. Yeah, get temp. Well, we could get temp C. We could do that. We can do that one. We can also write two more. If we don't want to get the temperature or get the Celsius, we could compare them using this method. What we're going to do is run a method call on A, run a method call on B, and see if they're equal. We could do a get temp C, get temp, but we'll work with C right now. Or we can get a get scale if it's C. Or I didn't call it get scale. What did I call it? I called it, I thought I wrote those. I thought I wrote the scale. Get value. Get scale, I have a set scale and I have a set value. But the gets, you're right. The gets are the temp C and the temp F. I could write another one that just returns it. In fact, here I'll do it just because this is what I kind of wanted to do. I can put one in here that says public. Let's say I don't want to get it in something, I just want to get it. I can also do this as well. I can go public float get scale, which is the method I wanted to write actually. And then this is just going to return, it's going to return scale. And then we can see if they're equal. So just for those people, right now I sped it up a little bit. I'm trying to slow it back down. I sped it up a little bit. Let me slow it down. Let me bring down the pace a little bit. I wrote another method to complement the code that I had already written before because I don't want to deal with this one. I could run this one. For the advanced people, run this one. For simplification's sakes, to make this example more understandable to a more beginning level, I'm going to scale it down a little bit. I have a method called get scale that I put in here instead of get temp C or get temp F. Actually, this is scale. This is going to get me this one. I could do the same thing for the value too. I can do a get value, set value, which is, I have a set scale, but I don't have and I have a set value. I can get a get scale, and I can put a get value in here too. Watch, I can do this. It shouldn't. Why should it give me an error? Oh, it's a scale's a character, you're right. I don't know. It should give me an error, you're right. I'm going to put here value. Why is it not giving me an error? Wow. Is it scale or is it an S? No? It's a character. Yeah. Don't know. I have to change this to value. For newbies, do you understand what I'm doing here? No? Okay, so previously, when we wrote this originally, we did a get temp C, which returned the temperature in a Celsius. It did a conversion on it and returned it in a Celsius form. And then we get a get temp F, which returned the value of Fahrenheit. And then we had, did I write anything to return the value, just as a value? No. But we had a set value, and we had a set scale that we wrote with it. But instead of just returning the raw value, we never wrote that. So what I did here is I just did some returning of some raw values. I'm just saying, give me the scale, give me the value. It doesn't really mean anything, but I'm going to use it in my comparison to simplify it. I can run any method I want to compare anything I want. If I want to compare apples and apples, if I do it this way, I have to do this 4 times. If I do a conversion and put everything all in the same, then I only have to do it twice. So, but I'm not going to write one of the methods for you, and I'll leave this for you. Actually, this is going to be the only part you'll have to do. But I'm going to write one for you so you can use the logic to figure out the rest of it. So I wrote 2 new methods, one called getScale and one called getValue, that are just getter methods that are returning the value and returning the scale. Because this, believe it or not, is private. If I pass an object to a class and it's private, this is, I hate to say this, but for you advanced people, if you made it, no, it wouldn't work if it was protected either. Protected is not going to work either. It's going to be private. Because it's private, I have to use the methods, the getsers and the setters, or in this case the gets, in order to retrieve the value, because I have to use a public interface to it, which is why I wrote those methods. So down here in this implementation down here at the bottom, I actually have this now, so I can go, what does it get? A dot get scale. That's what I wanted to write originally. If it equals C, so if A dot scale is equal to C, and then I'm going to go, and that's the ampersand, that's the shift 7 on the keyboard. Looks kind of interesting on there. B dot, let me write this code out and you'll see what I'm talking about. Scale equals C. This is the long way of doing it. Oh, I heard something really weird. It sounded like a trash can. Then do something. Well, what's it going to do? It's going to have to do another test. It's going to be simple. Let's say system out dot print line. What are we going to print out? We're going to print out they are both C. Okay. They are both C. Celsius. Celsius. Something like that. They're both Celsius. And then if A.getValue is equal to B.getValue, so I'm going to print it out here, and then I'm going to say, well, they're both Celsius, but are they both the same temperature? Are the temperatures equal? So I took this and I made it simplified in terms of this implementation. So the next line of code I'm going to do is I'm going to nest it inside, because this is showing you how to nest it, which is probably the reason why I designed it this way. So inside this if, remember I said you could put ifs inside of ifs? So in if here, I'm going to purposely indent it because I want to make sure it's visible. I can see that I've got it nested in here. I'm going to do the same thing, but instead of testing the scale, I'm going to test the value now. So A.getValue. That's why I had to write these two methods, because these two methods didn't exist. Equals, well, what is it going to equal? Does it equal B.getValue? If it equals, then it's going to do something. And what it's going to do is it's going to system out something. It's going to system out system.out.println. And what's going to print out two temperatures are equal. Okay, or 0, which is going to be the two temps are equal. Why do I have a message here? There we go. Okay, thank you. Sometimes when you stare at it longer than I do. So. All right, so we're going to test here, and we're going to return now a primitive. This is not the full implementation. This is just one of the tests, and this is kind of a, down here. Actually, I'll finish the rest of it here. I'll just say if the values, I started out here. So let's say here, I can go else if A dot get, I'll finish the first one for you. Value equals B dot get. It doesn't, wait a minute, if, what was I doing? Wait, I know what I'm doing here. Larger than B dot get value. Then, what is this one here? First temp is higher than the second. System out print line, which is what? 1. First temp is higher than the second. And then there's a third one here, else if A dot get value is smaller than B dot get value. And we have the scenario number 3, system.out.println, which is what, -1. that the second, first temp is lower than the second. So first temp is lower than the second. And I misspelled system. Okay, get rid of this box on the bottom so we can kind of see this here. So following this logic here, what I did, well, pseudo following this logic here, not really following, oh, I'm sorry, recopying that. Sort of following this logic here, I'll leave this up on the screen, I'm sorry. Of the different comparison, there was 3 different ones I wanted to do, and here's the trick to this one, which makes it a little bit different than the other one. In here we have an A and a B. We could have done an A and a B in here. I could have done temp other, I could have done temp A and temp B, that would have worked just fine. But it gets run by the instance. It's just a design choice. This one, it gets run by the class. It's the class because keyword static was included. And in here we have compared to temp A and temp B. And if A.getScale, and these are ampersands, it looks kind of funny. The font looks kind of funny, but it's the Shift 7 on your keyboard, ampersand. This is the AND logical operator AND. We have 2 of them. We have AND, and then we have the OR. The 2 lines here is going to be OR. So if this and this or this, but in this case we want AND. B.getScale, which means I'm coming up here and I'm running that method I have up there. .getScale is going to be equal to C. If they're both equal to C, then we know we have a match. If they're both equal to F, then we know we have a match. And what I did was this primitive little example here, and it did a conversion. You know what I did actually, which is kind of not the most optimal way of doing it in the sample, but so that I can write as many if-then statements as possible, is the next check is, are they both Fs? So underneath it you go, are they both Cs? If so, then look at this condition, this condition, this condition on the values. If they're both Fs, do the same thing. If one's a C and one's an F, then get the temp in C for the one that's in the F, so they're both equal, and then go through A, B, C. If one's an F and the other one's a C, then you do the opposite. You get the temp for the one that's the C, you get the temp in F. For the one that's an F, you get the temp in C. So you have apples and apples. And then you compare the value, are they equal or are they not equal? It's like 1, 2, 3, 4, I think 4 different checks you'll have to do on that. I did that to maximize the number of if-ends. You can break that out into 2 by getting rid of the get scale and the get values here and just do a conversion automatically. What the 2 are, if one's an F and one's a C, convert the F to the C. If the opposite, convert the C to the F. Check the values. So you make one equal to the other, check the values, or you only have 2 choices, an F or a C. It means you have 2 checks. If that makes any sense to you guys. Or you can do it for. I did it for only because I wanted to show you the if-then and the nested stuff. You know, it's not quite as complicated. Plus, some people, you know, didn't notice or didn't see the get scale, which I didn't put in there, or the get value, which is not really necessary. But I put those in. I'm not intending to run those from main because it makes no sense to get the scale or get the value when I don't know what it means. If I got the value out of there and the value was 70, I don't know the scale. I don't know, you know, I have no idea unless I ask for the scale. But I put that in there so I can break it out into those 2 components so I can check them in this function. The last part of this exercise I'm going to say is optional for you, but I gave it to you. I gave it to you in the Hello World example in code number 1. So I'm going to leave this, I'll leave this up during the break. You can look at it. So the driver program we sort of wrote already. And you can fill in the driver program. So you finish the logic here. Check for all the other conditions. In the driver program, just run the compare. In fact, we already have it. Oh, I think I lost my... Okay, I lost my battery, so it definitely is time for lunch. Let's finish this up after lunch. How's that? Because then I don't have to yell. So I think this is enough for right now. I'll leave I'll leave this up. It's actually going to be in the video, so you'll be able to pause. This has been sitting here for long enough, you'll be able to pause the screen of the video, write this stuff down if you missed it. This is the temp here. This is the rest of that class method over here. How we ran it was right here. This is the class method right here. I'm not going to post this source code because I don't want you guys to like turn it in as is. At least go through the effort of typing it yourself, kind of thing. But this is the assignment number 1. Yes, you may reuse this and submit it. It's not plagiarism. It's not cheating. I'm having you do it this way as a teaching aid. We're going to do the same thing with Dino after lunch. We're going to take a lunch break. And we're going to start in with a little bit of inheritance information. I'll finish this. What I need to finish on here is the command prompt. The rest of the assignment has you put in here, enter in, here we go. So you can type in a Java driver with a temperature and a Celsius and parse it out. I'll show you how to do that. You don't have to do that. This is optional. You can turn it in with this method completed and you're done with this program. If you want to optionally challenge yourself, for those people who want the option, you have to, you don't have to, but you can optionally implement the command line arguments. I have an example that will show you how to do that I'll show you after lunch. And then in order to run it, you can't run it in Eclipse. You have to run it from a command prompt or from a terminal screen so that you can type the name of the program space argument 1, argument 2. Argument number 1 and argument number 2 are going to be temperatures, a float and a character. And so you type the float and the character. If you remember from yesterday, the hello world that had the string arguments and that string array stuff, it's just that over again. That's an optional. You don't have to do it if you don't want to do it. You'll get full credit for it without it. I put that in there as optional because then you have to fix your class path if you're going to run it from a command prompt or terminal prompt, and then it's harder to do. It's harder to test it than using Eclipse. So. All right, I'm going to leave you with that. I'm going to leave this up here for those people who are still typing it in. And then let's have a lunch break. It's 12:30. Let's come back at, what, around 1:30? Is that good? Around 1:30? Is that enough time for everybody? 1:30 is fine. I'll see you at 1:30. In the meantime, I'll come around and help you, or you can come up here with your computers and I can troubleshoot problems that you're having. See you after lunch.